Okay, this is our third lab. First question is about the limit of a function using its graph. The first one is about the right limit at x equals 1. So when x approaches from the right hand side to 1, look at the graph, the blue curve. It goes to this little circle here, so this value is -1 here, right? So that's why the answer is -1. And when x goes to 0 from right hand side, and as we can see, it goes to -infinity. And from left hand side, this blue function, this blue curve goes to +infinity, right? So this is +infinity. Because these two limits are not equal, that means the limit when x goes to 0 does not exist. And the evaluation, E and F are evaluations, right? At 0, you take the solid dot. So here the value is 2. So that's why F0 is 2. And by the same reason, F1 is take the solid dot and take the F value, which is 1. Okay. The second one is the percentage of people who have broadband internet service in the United States can be modeled by this function. And the variable t is the time in years since 2000. And when t goes to +infinity, because the power here is -t, so it goes to -infinity. Something to -infinity is always 0, right? So it's 1 plus 0, which is 1 for the denominator. And that's why when t goes to infinity, the limit is 29.84. And this limit, when time goes to infinity, this is actually the carrying capacity of the broadband internet service in the United States, right? The percentage of people who have this service cannot be larger than this number. This is the maximum possibility, right? And part B, estimate the limit when t goes to 0 from the right hand side. So when t goes to 0, this something to the power 0 is 1, right? So that's why for the denominator we have 1 plus 12.5 times this limit is 1. So in total this is 13.5. That's the denominator. And numerator is this constant. So this gives us a number, and this number is a percentage of people in the beginning of who have this service in the beginning of 2000, right? Okay, that's question 2. And question 3 is use the graph to explain this, compare these two functions. So their difference is for function r at 2, it has this solid point here, so this function 2 is in the domain of Rx. But for Sx, there's only this circle here, so at x equals 2, so that means 2 is not in the domain. So for question 1, R2, you take the value for the solid dot, which is 1. This is R2. For S2, this value S2 does not exist, right? It's not defined. And the limit, but the limit both exist, right? For the limit, you take the right limit and the left limit and right limit here, the left limit and the right limit here, and both give you the number 4, right? So 4 is the answer for R and X by taking this limit, right? That's question 3. Question 4 is about average rate of change. So in the interval from a to b, a function its average rate of change, denoted by a, should be fb minus fa and b minus a, right? That's the formula. And basically use this formula, we can take this comparison. For example, from x from 0 to 8, if you look at the f function at these two ends, you get both 0, so the average rate of change for f is 0. But for g, this is a constant, have a constant slope, so the average rate of change doesn't depend on which interval you choose, and it's a positive constant, so that means g is larger. Let's take another example. Take this one from 5.2 to 6.1, right? So this is f at 5.2. So g at 6.1 minus g at 5.2 compare with f by the same formula. As we can see, these two numbers, g at 6.1, f at 6.1, they coincide with each other because they share the same point here. But f at 5.2 is smaller. This is f, this is g at 5.2. f is smaller than g, right? So, but we have a minus on here. Minus something smaller makes the numerator bigger. So that means the average rate of change of f is greater than that change of g, right? F is bigger. That's why f is bigger. So all the others are, the arguments are similar, right? You can take a similar argument and you will see the results. And question 5, find all the points of discontinuity of the function. So yes, I draw the graph of the function here. As you can see, the function is not continuous at x equals 0, right? It's kind of clear. Question 6, explain how it's possible for a function to have more than one average rate of change. So first of all, you need to know that the average rate of change depends on the interval, right? The interval AB changes. It's possible that the average rate of change can be different, right? Can be different. You take any nonlinear function, you will see this phenomena, right? For example, a quadratic function, when you change the interval you take, the average rate of change varies. Another possibility is you change the change of dimensions, right? If you have a function f, like when f0 equals 0, f of 1 equals 10. So from 0 to 1, the average rate of change is 10, right? But let's say that the variable is in years, so 1 is, the dimension is year. Let's change the dimension from years to months, right? Then 1 year is 12 months. So the average rate of change is f12 minus f0, 12 minus 0, which is 10 minus 0 over 12, which is 10/12. So this number is different from 10, right? When you change the dimension of the variable, the average rate of change can also change, right? That's the different possibilities how to get different average rate of change. Okay, that's it for Lab 3. Thank you for watching.